So, this video is going to be 7.2 homework, but I'm going to do 9 through 13 on this video. Because I think some of you have questions on them and just didn't want to ask in class, so here I go. Okay, number 9. Ooh. So we are finding an explicit and a recursive equation. So your first step in all of these is to figure out what the pattern is. What is happening each time? Okay. So for number 9, I have step 1, which means x is equal to 1 here. Step 1 is x equals 1. How many dots do I have? 1, 2, 3, 4, 5, 6. I have 6 dots. Yes? Okay. Pause me and figure out how many steps or how many dots you have in step 2 and step 3. Okay, so step 2 means x equals 2, and I have 9, 11. I have 11 dots. Oop, not 111, just 11. All right, and then step 3, which means x equals 3. I have, if you count them, you should get 16. Okay, so what's happening here? So my x's, which are my steps, those are just increasing by 1, so we're not going to worry about that. What's happening here? I'm going from 6 to 11 to 16. Am I adding the same amount? Am I multiplying by the same number? Well, it's getting bigger, so I'm either multiplying or I'm dividing. I'm getting more dots. So am I multiplying or am I adding? Yeah, I am adding from 6 to 11, that's 5 more. 11 to 16, that's 5 more. So I am adding 5 each time, or each step. Yes, we can say that, each step. Adding 5 each step. So if you're adding or subtracting, then that means your problem is linear. So that should bring this into your brain for writing an equation. Y equals mx plus b. Okay, you could also write it in point slope form. Y equals slope. Yeah, that's fine. X minus x1. Oops, 1. Okay, geez. There. So you can either, regardless, we know the slope. The slope is 5. We're increasing by 5 each time. That's our rate of change. So if I do y equals mx plus b, it's going to be y equals 5x. I don't know my y-intercept. It's not given to me. So your y-intercept is when x equals 0. So if x, what is this? Oh, there we go. So if x equals 0, how many dots will I have? This is where you do your pattern backwards. Instead of adding 5, I'm going to subtract 5. From x equals 1 to x equals 2, I added 5, and then I added 5, so I'm going to just go backwards. So I'm going to get 6 minus 5, which is 1, which is 1. 5x plus 1. If you did it in in point slope, that's fine. You can do y equals your slope, and then I can't remember which one they did. I don't have the answers out. They probably just did the first step. So it's x minus 1 plus 6. So you just substitute in your first point. So you could do 1 and 6. X is 1, y is 6. You could do 2 and 11. You could do 3 and 16. But this is the most common one you're going to see. So either one of these is fine. Number 10, we did in class, so I'm not going to do it again. All right, number 11. Find an explicit function rule and a recursive rule for the values in each table. So now you have tables. So you have to figure out once again, what the pattern is. What's going on from step 1 to 2, 2 to 3, 3 to 4? What are we doing? And remember, you have to do the same thing each time. Oh, okay. So we are from 1 to 11, 11, 21, 21. We are adding 10. Adding 10. Oops, 10 each step. So if we are adding the same amount, that means linear. It is linear. Adding or subtracting the same amount means linear, as opposed to multiplying, which would be exponential. Okay? So y equals, my slope is 10, and then my y-intercept, you just do the pattern backwards. So if x is 0, instead of adding 10, you subtract 10. You get negative 9. 10x minus 9. Or if you do it in point slope form, x, what it's going to do, I'll just use the first one, so x minus 1 plus 1. Okay, but really you could use any of these points in point slope form. 2 and 11, so it would be x minus 2 plus 11, or x minus 3 plus 21, so on and so forth. So either one of those is fine. Okay, number 12. Oh shoot, I didn't do recursive. Oh, I forgot about recursive. Recursive, f of n equals f of n minus 1. And then our pattern is we are adding 10. So that's, and then you need to write down where you start, f of 1 equals 1. This is explicit. This is recursive. Okay, let me go back up and do recursive up here. Sorry about that. Recursive then equals f of n minus 1, which just means your previous term, and then we are adding 5 each time. So plus 5, and identify where you start. We start at 1, y is 6. Identify where you start, and then there's your equation. Okay. So number 12, what's going on number 12? It looks like we are dividing by 2, which is the same as multiplying by 1/2. 16 times 1/2 is 8. 8 times 1/2 is 4. 4 times 1/2 is 2. All right, so here, I'll do the recursive first this time so I don't forget. So f of n, well, actually let's identify where we start. So the first point they give us is 2 and 16. All right, and then f of n equals f of n minus 1. That's your previous term, and then we are multiplying by 1/2, so I'm going to put it in front. So it's 1/2 times that. If you want to put the little multiplication symbol in between, you can, or you can leave it like that. That's recursive, explicit. Okay. We are multiplying by 1/2, so we are going to have exponential. This one is exponential, because we're multiplying by the same thing each time. So your exponential equation is y equals a times b raised to the x power, where a is your y-intercept and b is your ratio. Geez, sorry. Okay. Let me actually see what they did on this one, because did they give you the y-intercept? Probably not. Oh, they actually they did. Nope, they didn't do the y-intercept. Okay. So you could find the y-intercept, but the book did not. The book said of n. If you want to be writing f of x this whole time, or even y, that's fine. Equals. Right. They went ahead and just used the first thing they gave us. So 16 times our ratio, which is 1/2. And that is raised because we're using the second term. See how there's a 2 here? We're using the second term. We don't know the first term or the 0th term, so we're using the second term. So it's raised to the n minus 2. Technically, you could use any of these points they gave you. So if I did 8 times 1/2 raised, there it is, raised to the n minus 3. 3. So you're substituting into this equation. If you did find the y-intercept by doing your pattern backwards, so instead of multiplying, instead of multiplying by 1/2, I would multiply by 2. So I would get 32 for the first term, and then I would get 64. So 64 times 1/2. And that would be using the y-intercept. So any variation of those is fine. Finally, you have 13. So 13, you have to be careful. You're multiplying by -5. Okay, -5 times -5 is positive 25. 25 times -5 is negative 125. So you have to be careful with your signs. So the recursive would be identify where you start. So f of 1 equals -5. And then equals previous term. And then it's times -5. So I'm going to put it in front like that. I think that's how your book did it too. Yeah. Okay. But if you want to put f of n minus 1 times -5, that's fine. As long as I know you're multiplying your previous term by -5. Okay, and then you have explicit. So once again, we're multiplying, so it's going to be exponential. So then equals, if you use the first term they give you, then you have -5 times, okay, I'm getting -5 from there, times my ratio, which is also -5, raised to the n minus 1. If you did it with the y-intercept would be, so instead of multiplying by -5, you do the opposite. You go backwards. So I'm going to divide by -5, which will give me 1. -5 divided by -5 is 1. So with the y-intercept, it would be fn equals 1, -5 raised to the n. So really you don't have to write the 1, so it could just be -5 raised to the n. Okay. There you are. So this one, or really you could use any of these points. You could use 2 and 25, 3 and -125. Okay. So that's how you do those problems.